All right, let's explore completing the square with area models. This is the process by which we change a standard form quadratic into its vertex form. This one is a pretty simple one to start with. The idea of completing the square is that we literally want to make a square. And from this, I'm going to kind of group some things together here. And our square is going to have an x squared in the upper left-hand corner, which of course will mean that those have to be x's to multiply together to make that x squared. Because we want to make that a square, these on the diagonal have to be exactly the same size, and that is where together they have to add up to 5x. So we're going to have half of the 5x in one box and half of the 5x in the other box, which will make this a plus 5 halves and a plus 5 halves right there. Now, this is almost a square, except that this bottom right-hand corner has nothing in it, but we know what should be in there, and what should be in there is a 25 over 4, if we take a look at that. But if we're trying to compare what we have here so far to what we had in the beginning, well, first of all, we need to have a minus 13 out here. Let's kind of group this together here. And the problem is that this 25 fourths kind of came out of nowhere. So I need to subtract a 25 fourths from that so that these two pieces are equal to 0. And then if I look at the individual squares that are in here, then my x squared in here, okay, is plus the 2 5 halves squared are going to, or the 2 5 halves x's added together are equivalent to x squared plus 5x plus 0 here in the black minus a 13, so that is an equivalent expression. My next step then is to actually write this in a little more algebraic form, where my square, now instead of writing this as the area of 4 little rectangles added together, I'm going to write it as length times width of that square. So I get x plus 5 halves times x plus 5 halves minus 25 fourths. And we'll change this into a minus 52 fourths so we can combine those together. And we get f of x is equal to x plus 5 halves squared minus 77 fourths. And this is the vertex form of x squared plus 5x minus 13. We have completed the square to get it there. So there is our first example. Let's take a look at another one that's got a little bit more going on. In this one, we have a leading coefficient that is not 1, and we would like our square to have an x squared in the upper left-hand corner, so we need to rewrite this as a negative 3 times x squared minus 8x, and we'll leave the 7 out on the end and deal with it later. So this expression is equivalent to the first expression. By just distributing that back through, we can see that. So now let's change it up a little bit and make a square show up here. So we have the negative 3 still in front of this, but now, and we got 7 at the end. So let's build a square in here with an x squared in the upper left-hand corner. We're going to cover this x squared minus 8x, which means I need minus 4x in there and minus 4x in there to maintain the squareness of this. So that's an x and an x, and that would have to be a minus 4 to make that happen. And of course, negative 4 times negative 4 in here, in order to complete this square, we would need a plus 16 in there. But as it stands right now, this is not equivalent to the expression above it because of that extra plus 16. So I also need to subtract a 16 from there. So those are now equal to 0 when I look at them together. So as I rewrite again here, I'm going to have the -3. I've got the parentheses with the +7 out there, and my square, if I now write it as a length times width of the whole thing, that is an x minus 4 quantity squared, and I've still got the -16 sitting in here. So I'm going to have to do a little bit of a distributive property now, though I can see the basics of my vertex form here already. So -3 times x minus 4 squared plus 48 plus another 7. And so this is going to be g of x equals -3 times x minus 4 squared plus 55. And that now is the vertex form of -3x squared plus 24x plus 7. And there's a couple of examples for you of how we complete the square using an actual square in that model.